Here in Chapter 9, we look at making inferences with two samples. And in the first section, we'll be looking at the case when we're comparing a sample between two proportions. So to introduce the idea, let's consider the following scenario. So think about whether you plan to vote in the next presidential election in 2020. Let's say I split the responses into two groups, females and males. And the proportion of females that plan to vote will be P1. And then we'll let the proportion of males that plan to vote be P2. So a question is there a statistically significant difference between these two groups? So in this case, we don't actually care what those proportions are, but we just want to know whether they're different or not. And in this section, we will only deal with independent samples with random variables. So let's see how we structure the argument here. So suppose we have two proportions, P1 and P2. If they're equal to each other, then the difference between them will be equal to 0. So we'll first collect two samples from each population and find two sample means, or I'm sorry, two sample proportions. So, right, so we have two groups. We're collecting one sample from each group and finding their point estimates in each case. Then we will see, is there a difference between those two samples? In other words, if I subtract them, do we get anything close to 0? So of course we know that the closer their difference is to 0, the closer the two values are to each other. So say for instance our null hypothesis is that the two populations have the same proportion. In other words, in our previous example we would say the proportion of females that plan to vote is equal to the proportion of males that plan to vote. So that would be our null hypothesis. And our alternative hypothesis in this case is P1 is less than P2. For instance, of course, it could take on other forms depending on the situation. But suppose it's just this form that we see here. So what would we need to make a conclusion in this case? Well, if we know that P1 is equal to P1 hat is equal to P2 hat, well then there's no difference between those two samples, and so we would fail to reject our null hypothesis. If it's only slightly smaller, P1 is only slightly smaller than P2 hat, and we would still fail to reject. If P2 is greater than P1 hat, well that's opposite of what our alternative is here, so we would fail to reject in that case. And only in the case if P1 hat is smaller than P2 hat by a large amount, then we can reject the null hypothesis, and we would use that as evidence to support the alternative. So what we really mean by this now is going to be that the difference between P1 hat and P2 hat is going to be something on the negative side. So we would have to have a value that's on the negative side for P1 hat minus P2 hat. So we'll be looking at the differences between two samples. And to walk through the setup here, so the first requirement is that the samples are simple, random, and independent. We have at least 5 successes and 5 failures for each sample. The form of our null hypothesis will always be that the two proportions are equal. And the alternative hypothesis will take on one of the forms where either they're not equal, P1 is less than P2, P1 is greater than P2. And for our level of significance, of course we use alpha again here, which will be by default 0.05 when it's not given. And we usually think of this as something that depends on the seriousness of making a type 1 error. And below here we see the test statistic. Well, notice what it is essentially it's the test statistic that we were using for proportions before, but slightly adjusted, where here we have the difference between our point estimates and then the difference between our claimed proportions. And the values that we're using below here, N1 would be the sample size of the first population, or the first sample I should say, and N2 would be the sample size of our second sample. So the sample that gave us P1 for a P1 hat, for instance, would be N1, and the sample size that gave us P2 hat would be N2. And then here, P bar, Q bar, those can be found using this formula, x1 plus x2 over n1 plus n2. So in other words, it's sort of a combined P, a combined proportion, combining all of the successes between x1 and x2, and then dividing by the combined total of all the samples. And then Q hat, of course, would be 1 minus P, or sorry, Q bar would be 1 minus P bar. And then, of course, just like before, when we're doing the p-value method, we're computing the area either to the left of our test statistic if we're doing the left-tailed. So in other words, if we have P1 is less than P2, the two-tailed when we have P1 is not equal to P2, and the right-tailed when P1 is greater than P2. Essentially, this would be if we're on the negative side, and this would be if we're on the positive side. Now,